Welcome to our first journey discovering the lies we tell ourselves about our solar system every day. Not intentional lies, mind you, just those charming little certainties we take for granted that are, well, completely wrong. Today we're starting with the heart of our system, the Sun and the planets closest to us. Get ready to feel a bit naive, but hey, it happens to the best of us. Our brains love simple, linear explanations, while the universe prefers to mess with us with its annoying habit of being surprising. Let's get started. The sun is yellow. Here it is, the most innocent misconception of all. We've been drawing the sun yellow since we were kids, and those emojis always show it with that cute golden smiling face. Even Van Gogh painted it yellow in his masterpieces. And who are we to contradict a genius? Too bad scientists don't get moved by art and keep insisting that the sun is white. The sun actually emits light in all visible wavelengths: red, orange, yellow, green, blue, indigo, violet, in almost perfectly balanced amounts. When all these colors combine, the result is pure white light. So what's the deal? Why do our eyes see it as yellow? The trick is in our atmosphere. When white sunlight passes through the air, microscopic particles, nitrogen molecules, oxygen, water, vapor, dust, act like selective filters. It's a phenomenon called Rayleigh scattering. Shorter wavelengths, blue and violet, get scattered in all directions much more easily than longer ones, red, orange, yellow. That's why the sky is blue during the day. It's all that blue light scattered by the atmosphere. And that's why the sun appears yellowish to us. It's the original white light stripped of some of its blue. At sunset, when light has to travel through a much thicker layer of atmosphere, even more blue gets filtered out, and the sun appears intense red-orange. If you could see the sun from space, it would appear blindingly white. Every astronaut confirms this. Viewed from Earth's orbit, the sun is pure white. It's our atmosphere that makes us see it colored, like a permanent, natural Instagram filter. The sun is a ball of fire. We often think of the sun as a gigantic fireball burning in space. But this image is completely wrong. Anything that burns needs oxygen to maintain combustion. The problem is that in space, oxygen is rarer than a free parking spot downtown on a Saturday night. Definitely nowhere to be found. So how does the sun emit light if there's no combustion happening? Actually, the premise is wrong. The sun doesn't burn and isn't made of fire. Like all stars, it doesn't produce energy through combustion, but through a completely different process, nuclear fusion. In short, the sun doesn't burn, the sun fuses. Our star is a gigantic ball of plasma where nuclear fusion occurs, the same reaction that powers hydrogen bombs and that we've been desperately trying to replicate on Earth for decades with, let's say, modest results. In the sun's core, where temperatures reach 27 million degrees Fahrenheit or 15 million Celsius, hydrogen atoms move so fast they overcome their mutual electrical repulsion and fuse together. 4 hydrogen nuclei combine to form one helium nucleus. But here's the kicker. A helium nucleus weighs slightly less than 4 separate protons. Where does that tiny difference in mass go? It transforms into pure energy according to E equals mc squared. And what energy? Every single second, the sun converts about 4 million tons or 3.6 million metric tons of matter into energy. To give you a practical idea, it's like 800 Great Pyramids of Giza completely disappearing from existence every second, transformed entirely into light and heat. Every single second, for 4.6 billion years, this energy then takes an incredibly long journey to reach the surface. A single photon generated in the core can take 10,000 to 170,000 years to reach the sun's surface, constantly bouncing between particles like a ping pong ball in a giant washing machine. The light you see today was generated when woolly mammoths still roamed the Earth. If the sun were really made of normally burning material, coal, wood, natural gas, it would have burned out after a few thousand years. Instead, it's been going non-stop for billions of years and will continue for another 5 billion. A real workaholic of nuclear fusion. Hey Curious Squad, before moving on and answering the question, Be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. The Great Wall of China is visible from space. Here it is, one of the most popular misconceptions ever, one that practically everyone has heard at least once in their lifetime. The Great Wall of China is the only human-made structure visible from space with the naked eye, a fact so widespread you'll find it in school textbooks, TV quizzes, even tourist guides. It's the perfect mix of apparent logic and exotic appeal that makes an urban legend irresistible. Too bad it's completely, totally, absolutely false. The Great Wall of China is not visible from space with the naked eye. Astronauts who have been in Earth's orbit unanimously confirm this. They can't see it without optical aids. And we're talking about people who had all the time in the world to look for it, knowing exactly where to search. But how is this possible? The Great Wall is thousands of miles long. It must be gigantic when viewed from above, right? The problem is that length doesn't matter, width does. And the Great Wall averages 13 to 16 feet or 4 to 5 meters wide. Viewed from 250 miles or 400 kilometers altitude, the International Space Station orbit, it would be like trying to see a human hair from 33 feet or 10 meters away. But where does this legend come from? Probably a combination of factors. First, the wall is actually visible in high-resolution satellite photos, but those use powerful zoom and special filters. It's like saying bacteria are visible with the naked eye, because you can't see them under a microscope. Second, there's an older version of the myth that said the wall was visible from the moon. When the first astronauts debunked this version, obviously impossible, someone softened the legend by moving it to Earth orbit. But even this version remains false. Third, the appeal of human achievement. We like to think our ancestors built something so monumental it's visible from space. It's poetic, inspiring, and gives an epic scale to our architectural accomplishments. The reality is that no human construction is clearly visible from space with the naked eye. Highways? No. Cities? You can only see them as light patches at night, not as defined structures. And that no even applies to the enormous pyramids of Giza. Seasons depend on Earth-Sun distance. Here's the misconception that has probably fooled more people in human history. In summer, we're closer to the sun. In winter, we're farther away. It seems so logical, so intuitive. More heat equals closer, less heat equals farther. Elementary. Completely wrong. Earth reaches its minimum distance from the sun, perihelion, in early January, right when the northern hemisphere is in the depths of winter. That distance is about 91.4 million miles or 147.1 million kilometers. While the maximum distance, aphelion, occurs in early July when we're 94.5 million miles or 152.1 million kilometers from the sun. The difference of 3.1 million miles or 5 million kilometers might seem important, but it represents only 3.3% of the average distance. It's like standing 10 feet from a campfire instead of 10.3 feet, practically imperceptible. The real culprits behind seasons are Earth's axial tilt, 23.5 degrees, and the geometry of solar illumination. During our winter, the northern hemisphere is tilted away from the sun. Solar rays arrive at steep angles, have to pass through more atmosphere, losing energy, and spread over a larger surface area, decreasing intensity. It's like pointing a flashlight perpendicular to a table, or summer, versus at a very steep angle, or winter. Plus, winter days are shorter. At the winter solstice, the sun stays above the horizon for only 8 to 9 hours, compared to 15 to 16 hours in summer. Less exposure time equals less accumulated energy. In summer, it flips. The northern hemisphere tilts toward the sun. Rays arrive directly, daylight hours are longer. Result? Summer temperatures, despite being farther from the sun. The definitive proof? The southern hemisphere has opposite seasons to ours. While you're suffering through August heat, Australians are putting on heavy sweaters. But heads up, this apparent astronomical anomaly won't last forever. In about 10,500 years, perihelion will fall in summer and aphelion in winter, so in the northern hemisphere, summer will be even hotter and winter even colder. Venus is a star. How many times have you heard, "Look at that beautiful morning star," or "There's the evening star"? How many songs romantically reference this star of love that shines so intensely at dawn or dusk? It's one of the most poetic and widespread misconceptions in the world. Too bad Venus isn't a star at all. It's the second planet in the solar system by distance from the Sun, almost as large as Earth. And that intense glow isn't its own light, but reflected sunlight. This confusion is as old as humanity. The ancient Greeks actually thought they were two different objects. They called Phospheros, light bearer, what they saw in the morning, because it preceded sunrise, and Hesperos, evening star, what appeared at sunset. Only in the 6th century BC did mathematician Pythagoras realize it was the same object changing position relative to the sun. The reason Venus, like Mercury, appears in the sky as both morning star and evening star is because its orbit is inside Earth's. So, from our outer position, we always see it relatively close to the sun, never more than 47 degrees of angular distance. This means that, like modest Mercury, it's only visible shortly before dawn or after sunset. Shooting stars are real stars. Who hasn't looked up at the sky during a summer night and seen those magical light streaks across the darkness, thinking they were witnessing the fall of a real star? Nothing could be more wrong. Those vivid nighttime sparkles are actually tiny fragments of dust and rock, almost always no bigger than grains of sand or ice. They burn up in our atmosphere at about 62 miles or 100 kilometers altitude. But what are they? Where did they come from? Well, here's how it works. When a comet approaches the sun, heat causes part of its icy nucleus to sublimate, releasing dust and small rocky fragments. This debris spread along the comet's orbit creates a kind of rocky trail in space. When Earth, in its orbital motion, crosses one of these trails, the fragments enter our atmosphere at incredible speeds, 7 to 45 miles per second or 12 to 72 kilometers per second. Friction with air heats them to thousands of degrees, literally vaporizing them in a light streak that lasts at most a few seconds. Think about it. If shooting stars were really stars, it would be a cosmic disaster of unimaginable proportions. Even the smallest star has a mass hundreds of thousands of times greater than Earth's. If a real star fell toward us, we wouldn't see a graceful light streak. The entire solar system would be devastated. Real stars do move, but so slowly it takes centuries or millennia to notice a change in their position from Earth. When you see one of those light streaks cross the sky in a few seconds, you're witnessing the spectacular death of a cosmic dust grain billions of years old. The far side of the moon is always dark. Ah, the allure of the dark side of the moon. Not only is it the title of one of the most famous rock albums in history, but it's also one of the most entrenched misconceptions in popular astronomy. The idea that there's a side of the moon perpetually shrouded in darkness has captured the imagination of writers, filmmakers, and dreamers for generations. Too bad it's a completely wrong idea. The side of the moon we never see from Earth receives exactly the same amount of sunlight as the hemisphere facing us. That's why it would be more accurate to call it the far side rather than the dark side. But why do we have this widespread misconception? It's because of the moon's synchronous rotation relative to Earth. The moon takes exactly the same time to rotate on its axis, 27.3 days, and to orbit around Earth, 27.3 days. This means it always shows us the same face, like a dancer spinning while always keeping their face toward their partner. From our terrestrial point of view, we always see the same 59% of the lunar surface. The surplus, over 50%, is due to libration. The other 41% remains invisible to us, hidden on the far side. But invisible doesn't mean dark. The term dark might lead you to think this part of the moon never receives sunlight, which isn't true. In fact, the moon also rotates relative to the sun, so every point on the lunar surface experiences about 14 Earth days of sunlight followed by 14 days of darkness, regardless of which hemisphere it's on. It's like the moon has a day lasting a month, but the day-night cycle exists everywhere. In short, the entire surface gets progressively illuminated even though from Earth we can always see only the near side. Here we are at the end of our first journey through solar system misconceptions. 7 little lies we tell about our closest cosmic neighbors. And the beautiful thing is we've barely scratched the surface. The common thread is always the same: the human tendency to seek simple explanations for complex phenomena. Science constantly forces us to question apparent certainties. And fortunately, the truth is always more fascinating than the fiction we invented. Next time you look at the sky, remember, behind every seemingly obvious certainty lies a reality that's much more surprising and complex. The solar system is full of surprises, misconceptions to debunk, and incredible stories, and we've only just begun telling them. Expect a second episode soon. Okay guys, is there anything you don't understand about what we've told you? Let us know in the comments. And if you want to learn more about the solar system, check out the whole series we've dedicated to it, planet by planet.